Hello to all my students in managerial economics. This is a video showing on the PowerPoint presentation that I have posted on your MS Teams. This is a video showing on the demand function. So please pay attention as I discuss the lesson given on this PowerPoint. So what we're going to cover today is the mathematical model, specifically the linear equation that can be applied in our demand and supply analysis. If you are going to go back to your lesson in algebra, you will remember the linear equation. And always the linear equation specifies a given function between two variables, the dependent and the independent variable. And so we start from the functional expression that y is equal to f of x. That is written as y equals small letter f, quantity x, quantity. So what does this functional expression say? It says that y depends on the value of x. So basically, this expression tells us as to what between the y and x is the dependent variable or the independent variable. You will notice that there is that small letter f introduced in that expression. Such a small letter f as introduced in the expression, functional expression, simply refers to the phrase depends upon, or it could be also stated as function of, or in other words, it can also be verbally expressed as influenced by. So I will say y and q are dependent, or rather y is the dependent variable and x is the independent variable. And it is stated y is a function of x. The value of y, to specify, depends on the value of x. So it is y variable that which value depends on another variable which is x. So between the two variables, the y and the x variables, it is the y that depends on x. So clearly speaking, y is the dependent variable and x is the independent variable. We can actually give names to any dependent or independent variable, such as quantity or quantity demanded and price. In economics, we use these symbols of Q and P to specify the relationship existing between the quantity demanded or the quantity supplied with respect to the price per unit of the commodity. So that instead of us using the letters to represent the dependent and the independent variable as y and x, we are now making use of q and p. So y variable is replaced by q variable, and the x variable is replaced by the p variable. So that is to say, quantity is a function of price. Quantity demanded depends on the price of the commodity in the market. Or quantity supplied also depends on the price of the commodity in the market. Because in reality, if you go back to the market, before a buyer can decide how much to buy of the commodity, the buyer has first to know the price. So only after knowing the price that the buyer can now make a decision to buy more or to buy lesser amount of the commodity. Thus, quantity as a variable is a dependent variable because its value depends on another variable, which is the price. So that in dealing with the demand and supply function, instead of y and x letters to use to symbolize the dependent and the independent variable respectively, we will now make use of q and p. So that is how we express the functional relationship between the two variables, the y and the x, or the q and the p. Let us now go to the next slide, so that if this function of y and x is to be expressed in the form of an equation, specifically linear equation, we can give more information to the relationship existing between the two variables when the equation that we're going to use as a form is a point slope form. So here the equation stated as y equals a plus b times x, or a or y is equal to a plus bx, is a linear equation expressed in a slope intercept form. Now, take note that there are coefficients that are involved. We have b as the coefficient of x. Or shall we call this a and b as the parameters? These are the parameters actually in a given equation. So that b as a coefficient of x is actually referring to the slope of the equation. A stands as the value of y when x is 0. So it is the y-intercept, if you are familiar with a linear curve or a line that is downward or upward sloping. Okay, so a stands as the value of y when x is equal to 0. Notice that the linear equation can have a positive or a negative sign of the slope. That's why we have here one equation which is introducing the positive slope and the other equation which is introducing the negative slope. Y is equal to a minus bx actually expresses that the relationship between y and x are, or rather the relationship between y and x variables is inverse. That is to say, when the slope has an associated negative sign, it actually is indicating a kind of relationship which is inverse. Now, what is an inverse relationship? Inverse relationship when the two variables are moving in the opposite direction. So that if x will increase, y will decrease. That is what we mean by inverse relationship. Now, what about if the slope associated the slope has an associated sign of positive? When the sign of slope is positive, that indicates a kind of relationship which is direct. So, y and x variables are directly related. That is, if x will increase, y will also increase. Or if x will decrease, y will also decrease. So there is same direction between the two variables, the x and the y. Now, so if the relationship between the two variables is positive and the equation involved is linear equation, then we will express it in the form of the equation such as y is equal to a plus bx. But if the relationship between the two variables is inverse, this relationship can be expressed in the form of linear equation y is equal to a minus bx. So take note that this linear equation that we are using in this discussion is actually a slope-intercept form. Why slope-intercept? Because what is given in the equation are the values of your slope and the value of your intercept. B is your slope and A is your intercept. I actually make use of the term intercept here. The term intercept or intercept, if you can imagine a line that is either inclined upward or inclined downward. In that particular line, of course, a line is made up of two or more points. Okay. A point on the line that intersect the main axis of y is called the y-intercept. And a point along the line that intersect the main axis of x is called the x-intercept. Now, if you will imagine a downward sloping line, it actually has its y-intercept and x-intercept. Now, what does this value of a of the linear equation tells us about as to what kind of intercept it is? It is always the intercept on the y variable, on the dependent variable. So what is our dependent variable? Y is our dependent variable. So therefore, A is the y-intercept. Take note, whatever is our dependent variable, A is the intercept of that dependent variable. Since Y is our dependent variable, A is therefore the Y-intercept. Now, since we're talking about demand and supply, and as I have said in the previous slide, we're not anymore going to make use of the Y and X variables. Instead, we are going already to make use of the Q and P variables. So, if we are going to interpret A stands as the intercept or the dependent variable intercept. And what is our dependent variable between Q and P relationships? Q is the dependent variable, so A is the Q intercept. So where can we find that Q intercept? If you imagine a downward sloping demand curve, along that line of demand, along that demand line, okay, you will notice that there are points along that line that intersect the main axis of Q, and that is represented by the value of A. So that at Q intercept, the value of P is equal to 0. So what does that mean? It means the highest quantity that the buyer can buy when the commodity is given for free. So, in short, if the buyer is not paying this commodity in the market because it is given for free, how much the buyer could take in a given period of time. So that is how much the buyer is willing to take of the commodity when it is freely given in the market. So our equation now, or our functional expression, is